Okay, we are recording. Today's meeting is not going to be on, this morning's meeting information is not going to be on the quiz today. It's for the next quiz coming up later this week. And it shouldn't be that long. We shouldn't be here that long, especially if I get started right away. This is the last of the muscle business. So this is the beginning of week 4, believe it or not. And the module has been posted and the schedule's been posted, as you are fully aware of. And this unit is going to finish up the muscular system, not that much left to do. You have some lab exercises to do. And then we're going to start the nervous system, which will take up the rest of the course. So this begins, I'm going to begin talking about chapter 10 in your book. And I'm going to pull up a whiteboard right now so that we can get on with it. So in your book, chapter 10, the bulk of chapter 10 is all about just identifying muscles, locations, origins, insertions, and actions. There's not going to be much of that on the lecture material. In other words, I'm not going to go through each individual muscle and just name what you could otherwise look up in a chart. You will have muscle identification to do on the lab exercises this week. But the introduction to this chapter is more about how muscles move, how they act, how they're named. So I'm just going to write up here, chapter 10. It's just called the muscular system. Like I said, I'm not going to go through each individual muscle one by one. That would be crazy. There are anywhere between 500 and some to almost 800 muscles in the human body. The reason that I say there's a range is because it depends on what anatomist you talk to. Some anatomists believe that, for example, like the gastrocnemius muscle, what you and I call the calf muscle, that has 2 separate bellies to it, a medial belly and a lateral belly. And some anatomists call that one muscle, others divide it into 2 muscles. But the point being, there are so many muscles in the human body, there's no way we could possibly learn all of them in this short course. So let me just get started I will expect you to know this business at the beginning. Origin versus insertion. I know it was mentioned in the previous chapter 9. I purposely didn't mention it because I knew I was going to talk about that in chapter 10. What these terms, what they both mean, these are just points of attachment of our skeletal muscles. So that's what they are. The difference between the two, the origin or origins, many muscles have more than one origin, so it can be origin or origins. This is the point of attachment. When the muscle contracts, there is no movement. So I just wrote no movement. The insertion is the point of attachment or attachments where there is movement when the muscle contracts. So I'm just going to give you a quick example. Because this one's easy for us to identify. The biceps brachii, everybody pretty much knows where their biceps muscle is. The biceps brachii muscle, located on the anterior part of the humerus. So you touch your upper arm on the anterior surface, that's your biceps brachii muscle. The origins are actually on the scapula, but I'm just going to put in the shoulder region. And the insertion is at the radial tuberosity, which is the proximal end of the radius. So I'm just going to put, this is just an example of what I'm talking about. When we flex our biceps brachii, we make a muscle, we flex our biceps muscle. The movement occurs in the forearm. It's the forearm that moves. Your shoulder does not move when that muscle flexes. So that's a great example of origin versus insertion. Now, I'm going to talk about muscle movements. And there are three major categories that we can lump all of our muscles into as to the type of their functional groups. Okay, and so we have three main functional groups. It doesn't mean that a particular muscle can only be in one group. A muscle can actually be be considered to be a member of all three groups, but there are three main muscle group movements. And the first one, your book calls prime mover. I learned these as agonists. So if you hear me say the word agonist, it's the same thing as a prime mover, okay? And what this means is it's a muscle that has the major responsibility of producing a specific movement. So the classic examples, I'll be specific after I give you examples of these. I think your book gives you pectoralis major. That's the muscle, the sheet of muscle over our rib cage on our chest. It's the breastbone muscle, so the pectoralis major. This is the major agonist. It has the majority of movement in total arm flexion. And because that muscle produces arm flexion, we call it an agonist or prime mover. There are other smaller muscles that assist in that movement, but this muscle takes on the majority of responsibility of arm flexion. So we call it an agonist or prime mover. I'm going to give you a second example because it's the one I used up here, the biceps brachii. The biceps brachii on the anterior side of our humerus, our upper arm, it is the prime mover or agonist in forearm flexion. So when you bend your arm at the elbow, it's this muscle that is producing the majority of that movement. And we call that forearm flexion. Okay, so those are two classic examples of prime movers or agonists. Now I'm going to go on to the second group. So I'm just going to put a number 2. And those are antagonists. And as you might guess, antagonist muscles just oppose the agonist movement. So they are muscles that oppose agonists or prime mover movement. Sometimes antagonists also can help regulate, so they don't always just oppose, they can also help regulate the prime mover movement. They help stabilize or regulate that movement. So, so they oppose agonists. I'm just going to say also regulate / or comma assist agonists. And examples of these would be the opposing muscles to number 1 group. So I'm going to try to use the same muscles that I gave you examples for in number 1. So for we use pectoralis major for an agonist or prime mover. So the latissimus dorsi, which is a huge sheet of muscle on the mid to lower back, that is an antagonist to the pectoralis major. Oops. This is hard because every time I have to erase, I have to click the eraser and then click back to the pen. All right, so I think this is even a better example. The triceps brachii is an antagonist to the biceps brachii. And rather than write all of this business out, before I erase this board, I'm going to show you what I mean by antagonist and agonist movement. And I'm going to highlight this point. Antagonist muscles can also be prime movers themselves. They can also be considered prime movers. The easiest, simplest, in my opinion, way to learn this and remember it is flexion and extension. Those are two opposing movements. So if we just talk about opposing movements, it's easy to understand. Just flashed my video back up here. And just show you on my arm. So I'm going to hold my arm out to you like this, and here's my elbow, this joint. Flexion, the prime mover of flexing is this biceps brachii muscle, and it does this. It reduces the angle at this joint. But here's flexion. That's being done by this prime mover, the biceps brachii. Now, the opposing antagonist is under here, the triceps brachii. When I extend, that movement is being done by this triceps brachii. So those are classic examples of agonists, prime movers, and antagonists. Now I'm going to go to the third group. This is a little bit more complicated, but synergists. I always think of synergists when I hear that word. These are muscle movement classifications of muscles that assist. They're basically assisting. So I'm going to put assist. If I could spell correctly, it's Monday. So they provide assisting movements. So they're sort of supportive in function. And what they can also do is stabilize, particularly joints. They also stabilize what your book says, undesirable movements. So they're not prime movers, agonists, or specifically antagonists. They're sort of assisting movements at joints. The example that your book gives, so I'm going to use the same one for now, is your finger flexor muscles. If your finger flexor muscles run really from the base of your forearm all the way across your hands, your wrist, and your fingers. So I'm just going to write finger flexors. You can make a fist. You can clench your fist with all of your fingers. And even though those finger flexor muscles run all around and across your wrist, you can clench your fist without bending your wrist. And the reason is because there are synergist muscles in your wrist that are stabilizing the wrist joint as you clench your fist. So that's your classic example that your book gives, is that you can, all of the muscles around your wrist joint, which is fully movable, are stabilizing undesirable movements if you don't want to flex your wrist when you make a fist. A subcategory of synergists are fixators, F-I-X-A-T-O-R-S. These are specifically where synergists immobilize an origin of a bone. Then the prime mover has a stable base on which to act. So next to fixators, I'm just going to put, this is an example of a synergist that specifically immobilizes a bone. A classic example is the scapula, your shoulder blade. You can do all sorts of movements with your shoulders. Matter of fact, that's the most freely movable joint in the human body, which is also why it's one of the weakest, why it's damaged so often. But that rotator cuff area, that your shoulder joint, it's called the pectoral girdle, is so fully movable that you don't always want to move your scapula in conjunction with a movement of your shoulder joint. So there are muscles called fixators that immobilize the scapula. So I'm going to put example. That can immobilize the scapula when you do certain movements with your shoulder. So just think of fixators as immobilizers of certain bones, holding them in place when other movements are necessary. Another classic example are muscles. Sometimes it's faster for me just to cross out a misspelling. Muscles of posture. So when we stand, or I assume you're probably sitting right now, you can sit up straight because of muscles that are contracting. And what they're doing is they're immobilizing certain bones so that you stay stationary, you stay in place. It's not about movement, it's about stability, immobilization. Last thing I'm going to say about these three categories is that, I already said this, I'm going to write it. A muscle doesn't only have to fit into one of these three categories. A muscle can actually be all three: an agonist, an antagonist, and a synergist. All right, let's move on. I'm going to talk about naming skeletal muscles next, and there's just criteria for naming skeletal muscles. And so I'm just going to list this as 7 criteria for naming skeletal muscles. I learned this in a very different order than your book lists it, because when I was sitting in your seat, when I was a student, we had to memorize this. And so I have a little acronym that I use for it, but since your book goes in a different order, I'm going to try to stay consistent with that. And it's based, we name all of the skeletal muscles in the human body based on these 7 criteria. Let me first tell you that no muscle that I'm aware of includes all 7 of these criteria in its name. We have this list of 7 things. Most muscles just use 2, occasionally 3 of these criteria in its name. So let's get on with it. The first one is location of muscle. Okay, I'll number these. So many muscles are named by the location of where they are in the human body. I'll give you some examples. Your book gives the temporalis muscle. The temporalis is located right over the temporal bone of the skull. So we all know our temples are located on the sides of our head. The temporalis muscle gets its name because it's a sheet of muscle located over the temporalis bone. Likewise, what you and I call our forehead, there's a sheet of muscle called the frontal belly of the epicranius, the front that lies over the frontal bone. So temporalis is a classic example. The intercostal muscles are located, guess what, between the ribs. So they're they get their name based on their location. I'm going to give a third. Our rectus abdominis muscles. Forget about the word rectus right now, that's a different classification, but this word abdominis tells us, think of your abdominal muscles, your abs. Those are located in the abdominal area of the human body. That's where that name comes from. So location is the first one. The second one on the list is the shape of the muscle. Some muscles, not all, have their shape in the name. Classic examples are deltoid. That is the muscle that runs right over the top of your shoulder. This is a bit confusing. These muscles were named a long time ago, but delta in the Greek alphabet, guess what, is a triangle. And that muscle, the deltoid muscle, is triangular shaped. So it gets its name from the word delta, the Greek letter delta, which is a triangle. So the deltoid that runs over your shoulder is triangular shaped. Another classic example of shape is the trapezius. That is trapezoid shape. That is the muscle, in case you didn't know, in your upper back. I'm just going to draw a little cartoon figure here. There's a head, shoulders, and here's the torso of a human being. Here are the arms. This is the back side of somebody. The trapezius actually is almost diamond shaped. It looks like this. If you were to dissect a person's muscle, the trapezius, and it gets its name because it's trapezoid shape. Next on the list is the size of the muscle. That's a Z. Many muscles have the size of the muscle, designating the size of the muscle in its name. Things like the words maximus, that means big. Minimus means small. Spelling. So maximus means large, minimus means small. Something like longus obviously means long. Brevis means short. All of these words infer the size of the muscle. So gluteus maximus, the buttocks muscle, which by the way is the largest muscle in the human body, volumetrically, that tells us its name, maximus, tells us it's a very large muscle. There's also a gluteus minimus, which is smaller. There's certain muscles that have the word longus in the name, or brevis to mean long or short. Number 4, before I go to a new whiteboard, is direction of fibers. Oftentimes, muscle names have the direction of the fibers in the name itself. This word rectus, that means straight. So the rectus abdominis muscles, we know they're located in the abdomen, and the fibers run straight, actually parallel with the midline of the body. So a word like rectus, that means straight. A word like transversus, that means actually running transversely to an axis. So I always tell students transversus, think horizontal. And there's other words like oblique, that usually means diagonal. If these words, rectus, transverse, oblique, are in the name, it tells you the direction of the fibers. Classic examples are the rectus abdominis muscle that I already gave you. Those fibers are running straight with the midline of the body. Another example is the rectus femoris. Rectus means straight with the midline. Femoris means located on top of the femur. So that's on the anterior part of your upper leg is the rectus femoris. Transversus abdominis would be fibers running in a horizontal direction in the abdomen, or something like internal obliques. Those are muscles that the fibers run at a diagonal, like this. So transversus fibers typically run this way, obliques at a diagonal, rectus usually with the midline of the body or the axis of the bone in which they run. All right, I'm going to layer on a new whiteboard. And the next one on our list, I think, is number of origins. So some muscles in their name itself tells us how many origins that muscle has. So I'm just going to say name lists or describes the number of muscle origins. Just like the name says, classic examples are the one that I used earlier, biceps, brachii. Biceps means two. So there's two origins in this muscle. This word brachii tells us, believe it or not, location. That word means upper arm. So this muscle, the biceps brachii, its name tells us the number of origins and the location of the muscle. Triceps brachii that muscle, guess what? You guessed it, has three origins. And you know what brachii means now. It means upper arm. So that's a location word. Also, the last example I'm going to give you, quadriceps. The quadriceps muscles in the leg, four origins. All right, let's get on with number 6. Is location. Some muscles in their names tell us the location of the origins and insertions. So some muscle names have the locations of attachment points. That's what that means. Classic example, and this is the one that everybody always gives, it's a long name, a muscle called the sternocleidomastoid. All of that one long word tells us where the points of attachment are, the locations of the origins and insertion. Guess what? The origins of this muscle are the sternum. So the origins are the sternum and the clavicle. So that's where sternocleido comes from. And the insertion is the mastoid process of the temporal bone, up right behind your ear. So this long name of this muscle tells us exactly where the origins and insertions are located. And finally, number 7. Last but not least is the action of the muscle. Some muscle names describe the action in the name itself. So if the muscle has a name like flexor, extensor, these words describe the movement or action of the muscle. Another one might be adductor. Classic examples of this, a muscle called the adductor longus, that's found in the leg, and that adducts. It's a long muscle, that's where that name comes from, and the action of adduction is in the name itself. Adduction means moving toward the midline of the body. So this muscle is located on the medial upper leg, the inside of your leg, where the inseam of your pants would be. And that muscle, when it contracts, it adducts or moves the leg toward the midline of your body. So most muscle names have some sort of combination of these 7 criteria. So I'm just going to write that before we leave. Like I said, none of them that I know of have all 7 in them. Usually there's 2, sometimes 3. Now I want to highlight this in this lecture. Do spend a little bit of time before the next quiz, not today's quiz, but our following one this week, our one later this week. On page 283 in your textbook is a figure or diagram, figure 10.1, that outlines muscle actions. And it describes flexion, extension, abduction, and adduction. And I will ask you a few questions from that diagram, from that figure on quiz 6. So now I'm going to move on to a new topic, 10.3, which is fascicle arrangement. So I'm going to layer over this. We just have 10.3 and 10.4, and we're done for the day. Just to remind you what a fascicle is, and that applies to today's quiz. That was information we did last week. A fascicle is just a group of fibers that are bundled together by a connective tissue called perimysium. So just think of fascicles, they're just bundles of muscle fibers within a muscle itself. And fascicle arrangement, this helps determine the muscle's force, how much the strength of contraction, that's F-O-R-S-E, sorry, C-E, the muscle's force, and shape. So fascicle arrangement determines, for those of you who are going to watch this later, I try my best to use this this plastic pen on a glass surface, but it's not easy sometimes. All right, so what this means is common patterns of fascicle arrangement determine how the muscle behaves, how it acts. So here are the common patterns of fascicle arrangement, and I'm going to talk about how they dictate movement. We can have a circular pattern. We call these circular muscles, as a matter of fact. So the muscles that have this circular pattern of fascicle arrangement, we find them, these are muscles that surround body openings. We call these sphincters. So there are obvious ones, body openings like the mouth and the anus at the other end. So, but even inside of our, for example, our GI tract, our digestive system, we have other openings, muscular sphincters, circular muscular sphincters that open and close. And what that does is it regulates movement of stuff from one area to another. The mouth is the easiest example we can give. And surrounding the mouth, that's a U, surrounding the mouth is the orbicularis, orbicularis, orbicularis oris. Orbicularis means circular, oris means mouth. Location, so it's telling us the shape of the muscle in this one and its location, the mouth. The origins for circular muscles are around the outside of the circle. The insertions are typically on the inside of the circle. So if you have a circle, I'm going to draw your mouth, there's your lips. Around your mouth are a group of muscles, and the fascicle fibers run in this direction. That enables you to control your lips. So, but beneath the skin, we have this circular muscle called the orbicularis oris. I've just drawn it. The origins would be located around the outside of this circular muscle. So the origins for the orbicularis oris, for example, would be the mandible down here, the lower jaw, and the maxilla right under our nose up here, which is what you and I call the upper jaw. The insertions would be, I'm going to draw the insertions in red. The insertions would be around the skin of the lips, the inside of this circle. So once again, the origins are out here, and the points of attachment of insertion are on the inside. That allows opening and closing and regulation of movement from one area to another. All right, so that's circular. Get my black pen up here, go to a new page, and I'll just write number 2. This is the second type of fascicle arrangement or pattern of shape. They're called convergent, C-O-N-V-E-R-G-E-N-T, convergent. This just tells us that the fascicles and the fibers in them converge toward an insertion point. Just like the name says. These tend to create triangular that's supposed to be a T. These create triangular or fan-shaped muscles. Examples, these would be the pectoralis major. That covers the anterior side of your rib cage, your chest muscles. Also, the deltoid. So the fascicles all converge toward an insertion point. And the third type here. So I'm just going to draw. There's my cartoon head, shoulders, chest, arms. The pectoralis major muscle. There's your sternum, your breastbone. The pectoralis major muscle does this. The fibers converge onto a point just in your armpit, and it creates this triangular or fan-shaped muscle. All right, third type of fascicle shape and fiber direction is parallel. So we've done circular, convergent, and third and last is parallel fibers. These, the fascicles, and of course fibers within the fascicles run parallel to the axis of the muscle itself. So the example of these would be strap or spindle shaped muscles. I'll give you some examples. So the parallel fibers and the parallel fascicles within the muscle create an overall strap or spindle shape of the muscle itself. The biceps brachii, the one that we've used as an example a few times already today, that is considered a spindle-shaped muscle. A strap muscle would be something like the sartorius muscle. I know you don't know all of these muscles, but a classic strap-shaped muscle would be down here in the leg. There's a muscle that runs from up on sort of near our iliac crest of our hip bone across our leg like this, and it's a strap-shaped muscle that then inserts down here on the inside, the medial side of the tibia. I'll leave it at biceps brachii. I'm just going to write this is considered spindle shape. All right, now fourth one is pennate. This is the last arrangement of fascicles. This is a little bit more complex than the first three. Pennate, in this, the fascicles are sort of short fan-shaped arrangement, creating sort of a feather-looking type of muscle. So for pennate description, I'm just going to write fascicles are short and fan-shaped, and the arrangement is converging on a central tendon down the length of the muscle. So I'm just going to write converging. I'll draw a picture after I write this. Converging to central tendon of the muscle. So if here's a muscle, I'm going to give you a class. Well, there's three classifications of this. I'll be specific and draw all three of these. Unipennate, specifically means the fascicles insert into one side of the tendon. And they tend to look like this. The example your book gives you is the extensor digitorum, which is on the, what you and I call the outside of our lower leg, on the lateral side of the lower leg. So here's the knee, thighs up here, and here's the lower leg. This would be a left leg facing you. So this is the lateral side. The extensor digitorum is located in this area going down to the top of the foot. The muscle fibers tend to do this. If this is the central tendon of the muscle, the fascicles all converge on one side of it like this. So it's sort of a half a feather looking arrangement. Bipennate So I'm going to put a lowercase b here. This is more classic looking. So the fascicles insert from both sides. Of muscles, central tendon. This takes on more of a classic feather look. Example, classic example is the rectus femoris. That's one of the quadriceps muscles located up here in the thigh, but on the front. The rectus femoris kind of looks like this. It sits in the front. It has a central tendon running down the middle of it, and the fascicles all converge from both sides. So it looks like this. So unipennate is just one side. Bipennate, the fascicles and fibers come from both sides to create a feather looking. And finally, multipennate is just a little bit more complex, sort of bipennate variant. So the fascicles are arranged around smaller tendons and then in turn inserting into one large tendon. So around small tendons. I'll draw a picture. Inserting into one larger central tendon. This looks like multiple feathers. That's what it looks like. Classic example would be the deltoid, the shoulder muscle. And if we dissect the deltoid muscle, it's a triangular shape. I'm just going to draw the shoulder, and the deltoid muscle would be here. there's a central tendon that runs sort of through the middle of this muscle. Let me do this. Let's do a bird's eye view of the shoulder. Here's the deltoid muscle. There is a central tendon that runs down the center of it, but there's multiple smaller feathers with their own mini central tendons running into this one. Like this. So it looks like multiple feathers converging into one place. The arrangement of the muscles fascicles determine, this is important, I'm going to write this down. The arrangement of the muscles fascicles determines its range of motion and the muscle's power. How much force it can produce during contraction. So muscles with parallel fascicles shorten the most. So they have the widest, actually they contract the most, up to 70% of their length they can contract. So the fascicles shorten the most, but these tend to be weak in terms of power. So, but these are not the most powerful. The muscle's power is really determined by number. I'm going to underline this, the number of fibers, and particularly the large, powerful fibers in the fascicles and muscle. So the bottom line is bipennate, multipennate muscles, they don't move very much. They don't have a huge range of motion like the parallel ones do. So unipennate and parallel running fascicles tend to have a huge range of motion, but they're not super powerful. Conversely, bipennate and multipennate muscles shorten a little bit. They don't have a huge range of motion, but they tend to be the most powerful. All right, almost done. We just need to talk about muscles interacting with the bones to form levers, and then this is all finished. So I'm just going to write muscles and levers. I think this is 10.4 in your book. So a lever is just basically the strict definition of a lever is just a straight bar, a rigid bar that moves on a fulcrum when there's, a fulcrum is just a fixed point. So let me write this down. Lever is just a rigid bar that moves on a fulcrum. A fulcrum is just a fixed point. In human A and P, the lever is always a bone. And a fixed point is typically a joint, not always, but it's usually at a joint. So fulcrums are joints, the lever is the actual bone. The load, if you hear this word or read it, just means in human terms, it's the bone itself. And any additional load that we happen to be carrying. For example, just moving your arm in space, the load would be the bone itself. But if you're carrying something like a suitcase or you're trying to throw a baseball, the load includes that baseball or the suitcase, the thing that you're trying to lift. A power lever is just defined as something that has mechanical advantage. And the load is near the fulcrum. So not a whole lot of movement. A speed lever does not have mechanical advantage. It has mechanical disadvantage, and the load is far from the fulcrum. And it has fast and a lot of movement. So these tend to be very strong. These tend to be fast, but weak. And you know certain joints in your body are fast and weak, like the shoulder. That's how a baseball player can throw a baseball so fast, is because it's a speed lever, but it's also very weak. The load is far from the fulcrum. You know that. The baseball is way out at the fingertips, and the fulcrum is actually the shoulder itself. Power levers tend to move less, and but can move a much greater weight. Think of movements in the legs. If you stand on your toes, for example, there's not a whole lot of movement, not like throwing a baseball, but it tends to be very strong. And that's called a power lever because it has mechanical advantage and the load is actually near the fulcrum. It's not far away from it. Last thing, when we're finished, I'll just talk about class of levers as they apply to the human body. There's just first, second, and third class levers. First class levers, the fulcrum is between, there's a picture of this, I believe, in your book, so study the diagram. First class levers tend to be, the fulcrum is between the load and the efforts. For example, muscles, I think your book uses the example of raising your head. So if you are sitting up right now and you point your head toward the ceiling, those would be considered first class levers where the fulcrum is between the load and the effort. They have mechanical advantage, but they tend to be slower. They are less stable, they're more stable, but less movable. Second class levers are the fulcrum is at one end and the effort is at the opposite end. So the load is actually between them. That would be the example of standing on your toes. Both of these tend to have mechanical advantage. You can review these in the diagram in your book, but keep in mind these two have mechanical advantage, but are slower and they're also more stable. Third-class levers, the effort is between the load and the fulcrum, and most skeletal muscles in the human body are of this class. Not all, but most of the skeletal muscles of the body, they behave as third-class levers or levers. Classic hinge joints are classic examples of these. Things like the knees, the elbows, even the shoulder, which is not a true hinge joint, it's a ball and socket joint. These are opposite 1 and 2. These tend to be, these are at a mechanical disadvantage. So they're not really strong. They don't produce a whole lot of force. So, not strong, but very fast. So, the muscles around these levers are what tend to be strong. So, muscles tend to be thicker. Around these levers because of the mechanical disadvantage. So the muscles compensate by being strong and thick, whereas these muscles tend to be shorter around these class 1 and 2 class levers tend to be shorter and not as big because they have mechanical advantage of the lever itself. And the muscle doesn't need to be super strong to produce a powerful contraction or powerful movements. All right, guys, I'm done with this for the day. We are finished totally with muscles. After you complete all of your lab assignments, you can forget about the muscles for the rest of the term. Tomorrow, I will post the meeting invitation tonight for tomorrow's meeting, and we're going to start the nervous system. It's long, it's complex, it's difficult, so it will take all of your concentration. But it's our last unit, so we can see the light at the end of the tunnel. Let me turn off my recording here now.